Welcome to homework.
Already written it out, and I'll just walk you through one of my answers. So for all of these synthesis type questions, there are multiple ways to get to the product, so my answers only represent one possibility in mind as we're going through. So the first question asks us to generate this benzoic acid with a chloro on the meta position. So we can imagine you can access this by first generating this benzonitro group using HNO3 and H2SO4. This is strongly electron withdrawing, so it's going to favor the meta positions for the next electrophilic aromatic substitution. Using Cl2 and FeCl3, we can then generate the chlorine on this meta position. Reduction with hydrogen gas and palladium on carbon gets us to the amine. Now we can generate the diazonium salt using NaNO2 and HCl. Copper bromide gets us to the bromine, substituting that diazonium salt. And finally, we can finish off with the Refer-Motzky reaction using zinc metal and carbon dioxide to generate our desired benzoic acid. Second question asks us to generate phenol with two meta-chloro positions. Chloro substituents on the meta position. So again, we can start with benzene using HNO3 and H2SO4 to get to the nitro group. If we use an excess amount of Cl2 and FeCl3, we can access the chlorine on both of the two meta positions. Next, by using hydrogen with palladium on carbon, we can again access the aniline. Using NaNO2 and HCl gets us to the diazonium salt. And finally, using water under acidic conditions with H2SO4 at 100 degrees Celsius, we can generate our desired phenol. This works because the oxygen of water acts as a good nucleophile to do the substitution with the diazonium. Next, we need to generate this benzylamine, starting from benzene. So we can imagine that we can start by using a Friedel-Crafts alkylation with methyl iodide and the Lewis acid. In order for this to get through a single monoalkylation event, we'd want to run our benzene in an excess. After generation of toluene, we can react this with this specific reagent such that we can have an acylation event occur at the para position of the methyl group. Next, using lithium aluminum hydride, we can reduce down this primary amide into a primary amine to afford our desired benzylamine, Next case uses very similar strategies as the previous ones, but we want this benzoic acid with a para-ethyl group. So we can start off by using a Friedel-Crafts alkylation with ethyl iodide to generate this ethyl benzene. Ethyl benzene reacting with HNO3 and H2SO4 will attach the nitro group on the para position. Using the same strategies as before through reduction to the aniline, followed by diazonium salt formation, we can again replace this with bromide using copper bromide, and then go through another Refer-Motzky reaction to generate the benzoic acid. The next case, we have three different groups: an alcohol, a methyl, and a bromine. So we can start by generating the toluene with a Friedel-Crafts alkylation of benzene. Again, we'd have to use an excess, literally excess amount of benzene to generate the toluene, followed by nitric acid and H2SO4 gets us to the para-substituted nitrobenzene. Using Br2 and FeBr3 as a Lewis acid, we can again generate the bromine on the ortho position to the methyl group. So again, the nitro group is a meta-director and the methyl group is an ortho-director. So this bromine is favored to appear on either one of these two ortho positions. Reduction to the aniline followed by diazonium salt formation gets us to the diazonium on the position where the nitro was originally. And now we can use the same strategy as before, but H2O and H2SO4 at elevated temperatures would get us to the desired phenol. Lastly, we need this diaryl coupled product with 2 chlorine groups attached. So you can imagine one of these entire aryl groups came from an aniline reacting with a diazonium salt. So what we really need to access is this molecule first. We've already generated this previously, but we can start by using benzene, generating the nitrobenzene, chlorinating in excess to access both of the meta-substituted chlorine substituents, reduction followed by diazonium salt formation gets us to this compound, and finally, reacting with aniline, the lone pair of the nitrogen will resonate into the ring, and the para-position carbon will attack such that we can generate this diaryl coupled product.